Welcome to the next session of subject engineering mathematics, chapter 2 differential equations. Now in this session we discuss classroom workbook, that is questions on particular integrals followed by concept, right? Now let us start the session with question number 46. Open classroom workbook, question number 46. The particular integral of d square y by dx square plus 6 dy by dx plus 9y equal to 9x plus 6 is, options are given. First option is x, next one is x square, x cube, fourth one is x power 4. So we need to find the particular integral of this differential equation. Now when you look at this equation, RHS part is a polynomial expression. As we have seen in the last session, when we are finding particular integrals of polynomials, the result is again a polynomial. Now in all options, the expressions are polynomials. Second degree polynomial, first degree polynomial, third degree and fourth degree. So one simple way to find particular integral when options are given is verification of options. Now let us see. Actually this is in capital D form, d square plus 6d plus 9 of y equal to, this is 9x plus 6. Now in place of y I am taking first option. So this is verification of options. Just let us verify option A. So apply this to d square plus 6d plus 9 of option A. If I apply this to the option A, if I get this 9x plus 6, then this could be right answer, right? Otherwise I can go for option B or option C or option D. Now let us see. D square of x 0, 6 into derivative of x1 plus 9x. So therefore this is 9x plus 6 and this is nothing but q of x. So this is q of x. Therefore this is nothing but particular integral of this particular equation. Simple verification. Or we can do directly like this. The particular integral yp equal to 1 by f of d. Now this expression is d square plus 6d plus 9 of q of x. This is 9x plus 6. Now this denominator part is nothing but d plus 3 whole square of 9x plus 6. Now here the least degree term is 3. When you take 3 common, this is 1 by 3 into 1 plus d by 3 whole square. This is nothing but of whole square of 9x plus 6. Now therefore this is 1 by 9 into 1 plus d by 3 whole square of 9x plus 6. Now it is in the form 1 plus x whole power minus 2. So this is 1 by 9 into, expand 3's expansion, it is actually in the form 1 plus p whole power minus 2. I call it as p equal to d by 3. Now this is a polynomial expression of degree 1. Therefore I can expand this up to power 1 only. So this is 1 minus 2p of 9x plus 6. So therefore this is 1 by 9 into 1 into 9x plus 6, 9x plus 6 minus 2 into this p is nothing but d by 3 of 9x plus 6. So therefore this is 1 by 9 into 9x plus 6 minus 2 into 9, this is 18 by 3 6, derivative of x is 1. Therefore 6 will be cancelled. So this is 1 by 9 into 9x, this is x. Therefore the particular integral of this equation is option A. So it takes some time, but this is easy to verify. So when options are given to find particular integrals, better to go for verification, right? So therefore in this case option A is right option. Next we move to question number 47. A particular integral of d square y by dx square plus 5 dy by dx minus 3y equal to 6 is, options are given as constants. See here, right side expression is q of x. What is q of x? It is 6. It is a constant expression. So therefore in place of 6 you can write either exponential function or cos function. Let us see this. So it is question number 47. A particular integral of d square y by dx square plus 5 dy by dx minus 3y equal to 6 is, options are given. Now in place of this RHS6, we can write like this: 6 into 1. This 1 can be written as e power 0x, or we can write 6 into cos 0x. Therefore you can apply particular integral for cos or exponential function. Now this is very simple to get the result. We can handle very easily. Now let us see. Actually this is d square plus 5d minus 3 of y equal to, this is 6 into e power 0x. So yp equal to 1 by d square plus 5d minus 3 of 6 into e power 0x. Here it is in the form 1 by f of d of q of x. Q of x is e power ax. So here a value is 0. Now since 6 is multiplied with this, you can take before this 1 by f of d. 6 into 1 by d square plus 5d minus 3 of e power 0x. Therefore this is 6 into 1 by, replace d by 0 a. So 0 square plus 5 into 0 minus 3 of e power 0x. So this is nothing but 6 by minus 3. So this is nothing but minus 2. Therefore here at this moment we have applied case 1 of particular integral. Case 1 of particular integral. Therefore simply d is replaced by a. Because this 0 is not a root of this expression. Therefore d is replaced by a. A is nothing but 0. Therefore the result is 6 by minus 3. It is minus 2. So option D is right answer. Option D is right answer. We can handle this even by taking cos 0x also. So therefore in this case a is 0. So you need to replace d square by minus a square. This is one chance, and this is the simplest way to get the result. This is the particular integral by case 1 and that is the particular integral by case 3, but this is very simple. Okay. So note down these points. Next, let us discuss question number 48. Consider the following second order differential equation: y double dash minus 4y dash plus 3y equal to 2t minus 3t square. We need to find particular integral in this case. Options are given in terms of variable t. Here this is nothing but d square y by dt square. So this is d square minus 4d plus 3 of y equal to 2t minus 3t square. Here this d is nothing but differential operator with respect to t, because t is an independent variable. Now this is a polynomial expression. So we can find particular integral by using case 6, right? In case 6 generally we go for series expansions. But here options are there, so you can verify easily. What is option A? Option A is minus 2 minus 2t minus t square. So this is f of d. Now I am verifying. So d square minus 4d plus 3 of minus 2 minus 2t minus t square. So this is nothing but d square of this. d square of second degree polynomial. This is 2 factorial, but here minus is there. So here minus 2 minus 4 into d means d by dt of this. So this is minus 2 minus 2t plus 3 into this. So minus 6 minus 6t minus 3t square. Therefore, this is nothing but minus 2 plus 8t minus 6 minus 6t minus 3t square. So here this minus 2 minus 6 plus 8 will be cancelled. So therefore, this is nothing but 2t minus 3t square, which is nothing but the RHS expression. So this is nothing but basically function in the variable t. I call it as q of t. Therefore, when you apply, this is f of d. So when you apply f of d of option A, we are getting q of t. We are getting q of t. Therefore, this A is nothing but 1 by f of d of this. This A is nothing but option A. Basically, this is nothing but 1 by f of d of q of t. So therefore, basically this is nothing but particular integral. Particular integral. Therefore, in this case, the option A is right answer. So option A is right answer. Simple, just by verification of options, we got that particular integral is A. Suppose if you don't get q of t when you apply option A, just do the same verification by taking option B or C or D. Verification takes very fraction of seconds. Okay. So option A is right answer. Next we discuss question number 49. Classroom workbook question number 49. Suppose x into cos 2x is a particular integral of y double dash plus alpha y equal to minus 4 sin 2x, then alpha equal to, options are given. So we need to find alpha value. Here alpha is coefficient of y. It is a second order linear differential equation, of course non-homogeneous, and this is given as particular integral of this. So when you have right side function as q of x, this is basically function of trigonometric, that is sine. So when you want to find this particular integral, we need to apply case 3 or case 4. Now let us see. Yp equal to, Yp means particular integral, this is 1 by, in capital D form, this is d square plus alpha of q of x minus 4 into sine 2x. So here minus 4 is multiplied with this, you can take before 1 by d square plus alpha minus 4 into 1 by d square plus alpha of sine 2x. Now here a value is 2. So d square is replaced by minus a square, hence it becomes minus 4. Therefore, this expression yp equal to minus 4 into 1 by minus 4 plus alpha of sine 2x. Minus 4, 1 by minus 4 into 1 by minus 4 plus alpha into sine 2x. Now, let us see, here denominator should not be 0. If alpha is a number which is not equal to 4, then sine 2x will be continued till the end of particular integral. But in this case, the particular integral is given as x cos 2x. So x cos 2x is a particular integral. That means the particular integral is a multiple of variable multiple of cos function. That is possible only when denominator will be 0. See, if it is not equal to 0, when this should not be equal to 0, when alpha is not equal to 4, denominator will not be 0. In that case, I will get directly a non-zero constant at this moment. So sine 2x will be continued till the end of particular integral. But sine 2x is not a particular integral. Sine 2x is not a part of particular integral. So therefore, this denominator must be equal to 0. Are you following this? If this expression is not equal to 0, that means if alpha is a number, alpha is a constant. If alpha is a number which is not equal to 4, then this will not be 0. That means we are getting a non-zero constant at the denominator parts. Therefore, the answer will be constant multiple of sine 2x. But in spite of that, the particular integral is a variable multiple of cos 2x. That is possible only when denominator will be 0. Therefore, this minus 4 plus alpha must be equal to 0, implies the value of alpha is 4. So the answer is alpha equal to 4. Option C is right answer. Option C is right answer. Write down this. Now let us discuss question number 50. The particular integral of the equation d square y by dx square plus 4 dy by dx plus 3y equal to 3 times e power 2x is, options are given. So we need to find the particular integral of this equation. Right side is exponential function. So we need to apply either case 1 or case 2. So here the value of a is 2. Here if 2 is a root of this auxiliary equation, then we need to go for case 2. If 2 is not a root of this equation, we can apply case 1. Now look at this. I can find directly its yp. So yp equal to 1 by f of d means d square plus 4d plus 3 of 3 times e power 2x. Here a value is 2. So when you replace d by 2, this will not be 0. Therefore 2 is not a root of this equation. Therefore we can apply case 1. This is 3 times e power 2x divided by, replace d by 3, 3 square plus 4 into 3 plus 3. Therefore, this is equivalent to 3 times e power 2x divided by, this is 9 plus, this is 9 plus, this is actually a value 2. So, we need to replace a d value with 2. This is d is replaced by 2, a. So, this is 2 square plus 4 into 2 plus 3. Therefore, 3 into e power 2x divided by 2 square plus 4 2's plus 3. So this is 4 plus 8, 12 plus 3, 15. Therefore, this expression is e power 2x divided by 5. So this is my yp, e power 2x divided by 5. So option B is right answer. Next we discuss question number 51. It is if y equal to 3 e power 2x, y equal to 3 e power 2x plus e power minus 2x minus alpha x is a solution of d square y by dx square plus beta y equal to 4 alpha x with the boundary conditions y of 0 equal to 4 and dy by dx equal to 1 at x equal to 0. At x equal to 0 for some real numbers alpha and beta. For some real numbers alpha and beta. Then we need to find alpha and beta values. See, alpha beta values are like this. In option A, it is 3 4, B 1 2, C 3 minus 4, D 1 minus 2. So these are the values of alpha and beta. So let us solve this. It is a non-homogeneous equation, but right side is 4 alpha x. It is a non-homogeneous equation. So therefore, its general solution will be yc plus yp. Now this is basically yc expression. What is my yc? This is yc. And this expression is yp. So let me write out this. In this case, general solution is y equal to yc plus yp. Here yc equal to 3 times e power 2x plus e power minus 2x. Of course, constants are calculated because c1 is 3, c2 is 1. Here yp equal to, this is minus alpha x. Now, when you look at options, in all options, beta values are different. So, beta is 4, it is 2, it is minus 4, it is minus 2. So, if I identify b value, directly I will get this. Okay. Now, actually, this is actually constant c1, and here 1, this is constant c2, and these are the roots of auxiliary equation. What are roots? One root is m1 equal to 2. Another root is m2 equal to minus 2. Therefore, when the roots are like this, my differential equation will be like this. So, I can write at first auxiliary equation. This is m minus 2 into m plus 2 equal to 0. So, this implies m square minus 4 equal to 0. Therefore, the corresponding differential equation is d square minus 4 of y equal to 0. Therefore, this is nothing but d square y by dx square minus 4y equal to 0. Now, compare this equation with this. Now, let us compare this equation with this. In place of beta, we have minus 4. So, beta value is minus 4. Therefore, we got only one option with the beta value minus 4. Hence, option C is a right answer. Even you can easily find alpha value by finding particular integral. Find its particular integral and compare with these values, you can get the answer. And another one is directly by finding the value of beta, because in all options, at least alpha values are 3 and 3, repeated twice. Here 1 and 1. But when you look at beta values, in all options, beta values are different. So what I do is, if I find beta value without finding alpha, I can get the answer. So that's why I followed that strategy. I got beta value. Here beta is on the LHS of my equation. So therefore, when you find auxiliary equation, from that you can generate differential equation so that you can easily get the value of beta. So therefore, basically this is nothing but yc. Of course, c1 is 3 and c2 is 1. But what are the roots? 2 and minus 2. When the roots are 2 and minus 2, this is my auxiliary equation. M minus 2 into m plus 2 equal to 0. So it is m square minus 4 equal to 0. Therefore, the corresponding differential equation is this. D square minus 4 of y equal to 0. So it is d square y by dx square minus 4y is 0. Now compare this with the given question, then beta will be minus 4. That is happening only in option C. Hence, option C is a right answer. This is one of the workful question. Please note down these points. So it is question number 52. What it is? If the solution of the equation d cube minus d square minus 4d plus 4 of y equal to e power 3x is c1 e power x plus c2 e power 2x plus c3 e power minus 2x plus k into e power 3x, then what is k? So it is a third order equation. First time we were handling third order equation. It doesn't matter. So here the equation is d cube minus d square minus 4d, d cube minus d square minus 4d plus 4 of y equal to e power 3x. So what is the general solution of this equation? Y equal to c1 into e power x plus c2 into e power 2x plus c3 into e power minus 2x plus k into e power 3x. So if this is the general solution of this equation, then what is k value? Now let us handle this. It is a third order equation. So general solution contains 3 general constants. Of course, this is yc value. and this one is yp value. Now in YC, actually they may ask you this question directly like this. If the particular integral of this equation is k times e power 3x, then what is k? They may ask you like this. If the particular integral of this equation is k times e power 3x, then what is k? But why they gave us YC? Here in case of YC, the roots are 1, 2, minus 2. Here the value of a is 3. So it confirms that this 3 is not a root of this auxiliary equation. Therefore, you can easily apply case 1 to find particular integral. So here 1 is a root of this auxiliary equation. The coefficient is 1. Here coefficient is 2. Coefficient is minus 2. So 1, 2, minus 2 are roots of this auxiliary equation. Here when you are finding particular integral, this is e power 3x. That means a value is 3. Therefore 3 is not a root of this equation. So you can apply case 1 to get the particular integral. So here yp equal to 1 divided by d cube minus d square minus 4d plus 4 of k times e power 3x. K times e power 3x. Therefore, actually we need to find this. This is yp, but if you need to find a particular integral of this, then that must be equal to k into e power 3x. Now replace d by 3, e power 3x divided by 3 cube minus 3 square minus 4 into 3 plus 4 divided into e power 3x. So therefore this is e power 3x divided by this 3 cube is 27, 31, 31 minus 21, this is 10. Now therefore its particular integral is e power 3x by 10, but this is nothing but particular integral. Therefore the particular integral is this. Therefore k value is 1 by 10. Therefore in this case the value of k is 1 by 10. Just what we have done is we have calculated particular integral by case 1, and we have compared this particular integral with this k times e power x, so that we are getting k value as 1 by 10. Now with this we have finished classroom workbook on the constant particular integrals. Now we discuss a concept, that is Cauchy's linear differential equation. So the next concept is Cauchy's linear differential equation. Cauchy's linear differential equation. Let us see what is the general form of this equation. Suppose I have an equation in the form P naught into x power n d power n plus P1 into x power n minus 1 d power n minus 1 plus P2 into x power n minus 2 d power n minus 2 plus and so on Pn of y equal to q of x. So assume that the equation is like this. For future purpose I call it as equation 1. Now earlier when we started linear equations with the constant coefficients or non-homogeneous with linear constant coefficients, we don't have these terms. We don't have powers of x between p values and d values, right? See, just compare this equation with the linear equation with the constant coefficients. You can understand very easily. So between p values and d values, we don't have powers of x. So when you have powers of x as coefficients, handling is not a simple task. Till now we have solved many classroom workbook questions, that is differential equations with constant coefficients. But when you look at this expression, here what is the coefficient of the p naught into x power n? In this case p naught is a constant, no issues with p naught, p1 is constant, p2 is constant and so on pn. All these are constants. So we do not have any problems with the LHS coefficients. But between p values and d values we have x values, powers of x. So here d is nothing but d by dx as usual. This is nothing but differential operator with respect to x. Now between p values and differential operators, we have powers of x. One interesting point in equation 1 is powers of x and powers of d are same. This is n minus 1, n minus 1, n minus 2, n minus 2 and so on like this. So whenever if the equation is like this, such equations are called Cauchy's linear equations. Always remember one point, if you want to say that a differential equation is linear, just you make sure that all coefficients on the left side as well as right hand side are either constants or functions of independent variable. Since I am taking x as an independent variable, all coefficients of derivatives. What is the coefficient of d power n in this case? P naught into x power n. This is a variable coefficient, this is constant. Hence the overall expression P naught into x power n is a variable expression. Similarly, P1 into x power n minus 1, P2 into x power n minus 2. So all these are variable coefficients. Therefore, such equations are called Cauchy's linear differential equations. Now let me give one example. Suppose I have x square d square minus 2xd plus 4 of y equal to e power minus 2x. Now in this case, my p naught is 1. So P1 equal to minus 2, P2 equal to 4. Here Q of x equal to e power minus 2x. Therefore, this is a second order Cauchy's linear equation. Powers of x and powers of d are same. This is 2, this is 2. Here powers are 1. Next powers are 0. X power 0 into d power 0, that is 1. 4 into 1. So therefore, P1, P0 is 1, P2 1 is minus 2, P2 is 4, Q of x is e power minus 2x. Therefore, this is a second order Cauchy's equation. Now I will consider another equation. The equation is like this: x square d square plus 4xd minus 1 of y equal to, for example, e power minus 2x plus cos 3x plus, for example, sin x. So even this is also called as a second order Cauchy's linear equation. Now in this case, what is P naught? Coefficient of x square, it is 1, P1 is 4 and P2 equal to minus 1 and Q of x is a complicated expression. Even you can take 0 also. When you take 0 on the RHS, they are called homogeneous equations. Now I am taking non-homogeneous. So here this is e power minus 2x plus cos 3x plus sin x. Therefore, both are examples of non-homogeneous Cauchy's linear equations. Right? Note these points. An equation of the form P naught into x power n d power n, P naught into x power n d power n plus P1 into x power n minus 1 into d power n minus 1 plus P2 into x power n minus 2 into d power n minus 2 plus and so on plus Pn of y equal to Q of x. You call it as equation 1. Is called a nth order Cauchy's linear equation. Is called a nth order Cauchy's linear equation. Nth order Cauchy's linear equation, where P0, comma P1, comma P2 and so on Pn are constants. P0, P1, P2 and so on Pn are constants, and Q of x is either a constant or a function of x only. And Q of x is either a constant or a function of x only. Note down these two examples. Now our next task is solving equations of this model. So the next concept is solving Cauchy's linear differential equations. Solving Cauchy's linear differential equations. Right. Now, what is the drawback of Cauchy's equations? It is not a linear equation with constant coefficients. If it is a linear equation with constant coefficients, you know how to get the general solution. The general solution is obtained by finding complementary solution yc and a particular integral yp. If it is non-homogeneous, we get particular integral. If it is homogeneous, we get general solution as y equal to yc. That flexibility is there only when the equation is linear with constant coefficients. But in this case, the equation is not, it's a linear equation but not constant coefficients. Okay, so the problems the problem comes when powers of x occurs between p values and powers of d. So now my task is, I will try to get the general solution of equation 1 by eliminating powers of x between p and d values. Hope you understand. If an equation is a linear equation with constant coefficients, then I will get the general solution very easily by finding yc and yp as per requirements of the problem. You know how to get yc and how to find yp. If the equation is linear equation with constant coefficients, general solution is y equal to yc plus yp. But in this case, in case of Cauchy's linear equation, there is no doubt about that. It is a linear equation, no doubt about it. But the problem is, it's not an equation with the constant coefficients. What is the problem for us? In between p values and d values, we have powers of x. Now we try to get the general solution of such equations by eliminating powers of x between p and d values. Let us see how to get this. Suppose I consider previous equation as one, that is f of d into y equal to actually q of x. But actually here we have between powers of x and powers of d, I call it as, for example, f of xd. f of xd equal to q of x. Now I want to get the general solution of this equation. So therefore, in order to get the general solution of this equation, I take x equal to e power z. So first time I am converting independent variable x into new independent variable z. Inside this f of xd, what is d? D is nothing but a differential operator with respect to x. So when I take x equal to e power z, what will happen is xd becomes theta. Here what is theta? Theta is nothing but differential operator with respect to z, because x is converted to z. X is independent variable. First time we are converting independent variable x into another independent variable, call it as z. So x equal to e power z. But I am not changing dependent variable y. So when x equal to e power z, the changes will be like this: xd equal to theta, comma x square d square equal to theta into theta minus 1, comma x cube d cube equal to theta into theta minus 1 into theta minus 2. If I take x power 4 d power 4, since there is a number 4, I get 4 terms. It will be theta into theta minus 1 into theta minus 2 into theta minus 3 and so on. Now when you look at all the equations, on the LHS side we have powers of x and powers of d, but in the RHS side we have only theta terms. If the power is 1, I get 1 term. If the power is 2, I get 2 terms. So theta into theta minus 1. Always you need to decrease theta value by 1. X cube d cube equal to this 3 terms. X power 4 d power 4 equal to 4 terms, like this. Now what is theta? Theta is a differential operator with respect to new independent variable z, because before converting x into z, what is the differential operator with respect to x? But x is converted to new independent variable z. Therefore, I must convert d into some differential operator which I call it as theta. Got it? Now when you substitute all these in equation 1, then equation 1 becomes an equation with constant coefficients. And you know how to handle equation with constant coefficients. In that case, the general solution will be y equal to yc plus yp. But we get this general solution in terms of y and z only. But the question is given in terms of y and x. Therefore, finally this z is replaced by log x. Z is replaced by log x. Therefore, when you want to handle Cauchy's linear equations, the simple technique we need to use is take x equal to e power z. So by taking this, constant variable coefficients can be converted into constant coefficients like this. Therefore, finally the equation becomes an equation with the constant coefficients, and you know how to get the general solution by finding yc and yp, complementary solution and particular integral. So but the problem is the result will be in terms of y and z, because x is already converted to z. There is no more x at this moment, but finally z is replaced by log x. Okay, note these points. Consider a Cauchy's linear equation. Consider a Cauchy's linear equation f of x d y equal to q of x. F of x d of y equal to q of x. Call it as equation 1. The general solution of equation 1, can be obtained as follows. The general solution of equation 1 can be obtained as follows. Let x equal to e power z implies xd equal to theta, x square d square equal to theta into theta minus 1, x cube d cube equal to theta into theta minus 1 into theta minus 2, x power 4 d power 4 equal to theta into theta minus 1 into theta minus 2 into theta minus 3, and so on. Where theta equal to d by dz. Substitute all these in equation 1. We get an equation with constant coefficients. Substitute all these in equation 1, we get an equation with constant coefficients. Therefore, the general solution is y equal to yc plus yp. The general solution is y equal to yc plus yp. Highlight this. Where z equal to log x. I think this point is very clear, right? Next concept, we discuss one definition, that is Wronskian. When you look at this term, it seems to be a very surprising word. Let me tell you what is Wronskian. Actually, Wronskian is a famous mathematician who invented differential equations. So on his name, there is one concept that is called Wronskian. Suppose we have two functions y1 comma y2 in the variable x. Two functions y1 and y2 which are expressed in the variable x. Then the Wronskian of y1 comma y2 is denoted by w of y1 comma y2. This is nothing but Wronskian of y1 comma y2. Since we are working with two functions, this expression is nothing but a 2 by 2 matrix determinant. The first row is y1 y2, second row is y1 dash y2 dash. So here y1 dash is a first order derivative of y1, this is a first order derivative of this. Therefore this is nothing but find the delta of this into this minus this into this. So y1 into y2 dash minus y2 into y1 dash. Therefore this expression gives Wronskian of two functions. If I take three functions, then my Wronskian will be like this: w of y1 comma y2 comma y3 equal to, since we are working with the three functions, the result is a 3 by 3 matrix determinant. So the first row is y1 y2 y3. The second row is first order derivatives of these three functions, y1 dash y2 dash y3 dash. And the last row is second order derivatives, y1 double dash y2 double dash y3 double dash. Therefore when you are finding Wronskian of n functions, it is a n cross n matrix determinant. The first row take all functions in that particular sequence. In the second row, you consider first order derivative, third row, second order derivatives, like that. So as many rows as you can extend, that depends on the number of functions for which you are going to find Wronskian. Okay. Now let me give one example. Suppose if y1 equal to cos 2x, if y2 equal to sin 2x. Now let us find the Wronskian of these two. W of y1 comma y2 equal to 2 by 2 determinant. This is cos 2x sin 2x, derivative minus 2 sin 2x. Its derivative is 2 cos 2x. Therefore, this is 2 cos square 2x plus 2 sin square 2x. So this expression is 2 times cos square 2x plus sin square 2x. So this is 2 into 1. Cos square a plus sin square a equal to 1. Therefore, this is nothing but 2. So Wronskian of cos 2x comma sin 2x is always 2. So therefore, the generalized point is Wronskian of cos ax comma sin ax equal to a, where a is some constant. This is one important discussion which we use in the next concept. We call it as variation of parameters. Okay. So for the time being, let us write these equations followed by examples. Wronskian. Let y1 comma y2, let y1 comma y2 be two functions in the variable x. Let y1 comma y2 be two functions in the variable x. First off, the Wronskian of y1 comma y2. The Wronskian of y1 comma y2 is denoted and defined as, the Wronskian of y1 comma y2 is denoted and defined as W of y1 comma y2 equal to det of y1 y2 y1 dash y2 dash, det of y1 y2 y1 dash y2 dash 2 by 2. This is equal to y1 into y2 dash minus y2 into y1 dash. Okay, so you write this as note. Wronskian for three functions followed by this example. This is an example, and then this is one conclusion. This is note. Note these points. This is the end of this particular session. Thank you so much. We continue next concept in the next session.